going to do what people like me love to do best, and that is, of course, turn off all the lights. Because, of course, my friends, the first rule of stargazing is you can't see the universe with the lights on. And as we turn off the lights, we see in all of its glory, ladies and gentlemen, the Perkins Observatory planetarium. Okay, that's the second walk I'm going to do. Well, of course, we don't have one of those. How many of you have been to a planetarium at some time or another? Then you know that a real planetarium, this is a real planetarium, but the kind of planetarium you're used to is pretty accurate. You know, in case you haven't noticed, the sky is shaped like a bowl. Go out and take a look. The sky is shaped like a bowl. This is probably the first thing that human beings noticed about their universe, that it was a hemisphere up there, a place so intimately close to them that they honestly believed, many of them, that if they had a ladder tall enough, they could climb it and reach up and touch the edge of everything that is. The second thing they probably noticed through careful observation is that every single evening the sun sets over here in the west, and every single morning it rises over here in the east. Get the picture, my friends? What that means is this startling, amazing, almost scientific conclusion. A drum roll, please. There must be another bowl in that direction. Go ahead and take a look. Well, I'm sorry. I guess you can't see it, can you? Because Earth is in the way. And that's the point. You will never be able to see the other side of the sky, the other side of the universe, from where you stand or sit. But you know it has to be there because it's where the sun goes at night. Of course, if you put those two hemispheres together, you get a sphere. The great celestial sphere that surrounds planet Earth. And for a lot longer than we have known otherwise, my friends, that was the universe. Now, of course, we don't have one of those bowls like they do at a real planetarium, and we don't have one of those spheres, but if you use your imagination, hey, there it is. Special effects, no extra charge. Now, I just happen to know that rising at about 4:30 a.m. tomorrow morning, if it happens to be clear, it's worth getting up at about 4:45 to see. This will be a beautiful crescent moon, 26 days old, the thinnest splinter in the sky. But I hope that you'll go out and look at the moon sometime when it's full. And, my friends, you don't need a telescope as big as a corn silo to do astronomy. All you need is a simple pair of binoculars. I got my start when I was 10 years old with a $3 pair of flip-open plastic lens opera glasses. You know what I'm talking about? And with those, I was able to see those tiny little circles on the moon, which everybody calls, of course, craters. That's right, big holes in the ground. That's right. You came all the way up to Perkins Observatory tonight to see some big holes in the ground. And you're not going to be able to see them because it's cloudy. But first of all, I need to find out how many of you have binoculars at home. How many of you have neighbors with binoculars? How many of you are the neighbors with binoculars? I knew it. Well, in any case, we don't have to go borrow those binoculars, and just a simple look at the moon will show those tiny little circles. Now, you should be amazed by this, because, of course, those circles, those craters were caused about 4 billion with a B years ago when the Earth and the Moon, as co-planets, were minding their own business, orbiting around the sun, when all of a sudden, over about 500 million years or so, a whole lot of gigantic hunks of rock called asteroids slammed into the moon going at 100,000 miles an hour. And trust me on this, folks, if you take a hunk of anything and slam it into the ground going at 100,000 miles an hour, it's going to make a big hole in the ground because it's going to explode with the power of many of your puny earthling hydrogen bombs. Now, what you should be amazed by is that the holes are still there after 4 billion years, because the moon is only about 250,000 miles from planet Earth. Don't you just love it when people like me say only 250,000 miles, but that's close. Which means that if gigantic hunks of rock were slamming into the moon, they were also slamming into planet Earth. I just went outside and looked, and no craters. Now what that means is Earth must have some stuff that either scrubbed or washed or sandpapered our craters away in that 3 and 4 or 3.5 billion years. And what would one of those things be? Water, that's right. And not just that water that falls from the sky, but also giant blocks of ice that every few tens of thousands of years come grinding down from the poles, wiping out everything in their path. What are they? Glaciers, my friends. But there is another force, insidious, working all the time. It's all around you. What is it? The air, that's right, your atmosphere. Give that 4 billion years to work, move it around, and it will grind away the tops of mountains. The implication of all of this is that the surface of our Earth is new. It's constantly rearranging itself and changing. So if you want to know how your own planet was formed 4.5 or so billion years ago, you are out of luck. Luckily for us, we have a museum, an archaeological dig that we can go to that's just 250,000 miles away. And what those tiny little circles, those craters tell you, is that your planet and the moon were formed out of incredible violence, as little rocks slammed together to form bigger and bigger balls of molten rock, that the moon itself was formed from a giant impact of a planet the size of Mars slamming into planet Earth. And all of that happened a long, long time ago. And what you are seeing when you look at those tiny little circles on the moon is evidence of the last of those rocks slamming into the moon during the late bombardment period that ended about 3.5 billion years ago. And you can tell just by looking. So look. Now, I said that the moon was 250,000 miles away. Everybody knows, of course, how far away 250,000 miles is. Me neither. So, I'm going to try to express these numbers in a way that astronomers like to express them. And it's this way. That the light from the sun bounces off the moon and takes about 1 1/3 seconds to get down to your eyeballs, about this long. which means that the moon is about 1 1/3 light seconds away. And that perhaps is the most remarkable thing that I will tell you. What that means is that you are seeing the moon the way it looked 1 1/3 seconds ago. And what that means is that from the point of view of your perception of the world and the universe around you, there is no now. Now is an illusion. Even the light bouncing off the person next to you takes the tiniest fraction of time to get to your eyeballs and to be processed by your nervous system. You never see things the way they are. You see them the way they were. And the farther we go out into space, the farther into the past we look. So that if we look at a planet like, let's use the other one, setting over here beautifully in the western sky, the planet Venus, how many of you have seen her? I think she is, don't tell me no. I think she is about 15 minutes away by light beam right now. The planet Venus is named, of course, after the goddess of love and beauty. And if you have seen her shining so gloriously in the west in evening twilight, purest white, then you know why the ancients thought that planet was the goddess of love and beauty. Of course, they were wrong about that. In fact, if you were to look for the worst place in the solar system, the nastiest place, besides perhaps the surface of the sun, then Venus is where you would go. And a lot of that arises out of the fact that when you look at the planet Venus in a telescope, we would have shown you tonight, and you would have said, what? If I wanted to see a dot, I could see a dot at home. Because Venus shows no surface features whatsoever. It always shines the purest white because it is covered with a very thick layer of clouds. And oh, by the way, those clouds are made of sulfuric acid. But that's not the worst part. The worst part is that underneath those clouds, there's never a break in those clouds, is an atmosphere so thick and chewy, made up mostly of carbon dioxide, that if you were sitting on the planet Venus right now, the weight of the air above your head would squash you splatto, flatter than a pancake. But that's not the worst part. The worst part is that atmosphere acts like a blanket. It holds in the heat from the sun. You should be glad of this. We have a fairly thin blanket, and it keeps Earth at its distance livable. But Venus is a little bit closer to the sun. And the light from the sun shines through those clouds. It's always a cloudy day on Venus. Bounces off the ground, turns into heat. If you don't believe me, then you know that this happens. Try walking across a blacktop in your bare feet on a sunny day in summer, and you'll know what I mean. The trouble is, the heat can't get very efficiently out. And also, because of high winds in the atmosphere, everywhere you go, North Pole, South Pole, equator, and everywhere in between, if you were holding a thermometer in the brief moment before you were crushed flatter than a pancake, that thermometer would read 900 degrees Fahrenheit, which is about twice as hot as your oven ever gets at home. You want to know what it's like on Venus? Go home, turn your oven all the way up, stick a chicken in there, and see what happens. That's what would happen to you on the planet Venus. But that's not the worst part. The worst part is that you have those sulfuric acid clouds, which, not so sure about this one, would probably, well, what happens with clouds on Earth?
Rain.
Rain. Well, what you might get is rain. What you might get is a gentle sulfuric acid mist that dissolves what's left. A very wise astronomer, Carl Sagan, once said that on Earth, you don't so much live on planet Earth, you live in its atmosphere. On Venus, you wouldn't be living in its atmosphere. You'd be part of its atmosphere. A gentle wisp of gas is all that would be left of you. So, I predict that someday this century, before the end of the first half of the century, human beings will walk on the planet Mars, but they will never walk on planet Venus. It would just be too much trouble to do so. Now, of course, in the evening sky right now, if you want to look at anything at any distance, you've pretty much covered the solar system, at least the large objects in it, and you would have to go to the stars. I think I'll use my, I don't know, let's use this one. And the constellation I always go to when I'm looking at the stars, especially on occasions like my birthday or the end of my 40th year of teaching, is the constellation Leo the Lion, which is right now pretty high in, I see it's turned over a little bit. It's just turned over into the southwest just after it gets good and dark. Come on now. That looks like a lion, doesn't it? Come on. Oops. Wrong way. Let's see. Am I in the wrong? Oh, yes, I'm in the wrong star map, excuse me. Smoke them if you got them. You know, a lot of people think Leo doesn't look like a lion, but let me show you. Lion! Like I said, well, you know, okay. So, what I'd like you to do sometime, and for this you can just use your eyeballs, in other words, the binoculars you were born with, is find the sickle here, backwards question mark that forms the head and the mane and the front paw of the lion, and then that's the star Rigel, and then go to the other end of the lion, which is a star called Denebula, which means, how shall I put this, the other end of the lion, if you know what I mean, and I think you do. What's the tail? What did you think I meant? Well, we're going to look at Rigel, because Rigel right there is not 1 second away by light beam like the moon, but it is 77 years away by light beam. That would take too long now, wouldn't it? But I have a plan, and I hope that you'll have a plan too. When and if I am so lucky, I reach my 77th birthday, I am going to go out and look at the star, Roger, and I am going to think these thoughts, that on or about the day that I was born, the light that comes from that star erupted from its hydrogen bomb surface and took my entire life to get down to my eyeballs. How far away is the moon? How far away are the stars? Years, lifetimes, many lifetimes away. And the star, the lion's tail, the nebula, is, it just so happens, about 40 years away by light beam, which just happens to be. I did this as I was grading my papers one evening over the last week. I went out and looked at the nebula and remembered the first paper I ever graded 40 years ago. Now, of course, if you're looking at stars, I mean, this is kind of boring. And there are just so many things to see in a pair of binoculars. Perhaps one of my favorite binocular objects, I'll just point it out. So much to say, and I've talked at you too long already, is in the constellation Cancer the Crab. And no, I know it doesn't look like a crab, but look at it over here in the southeast, as well, or farther to the southwest. And you will, if you look right in the center of the upside down Y in a pair of binoculars, you will see a beautiful cluster of stars. And stars, my friends, are born that way. They are born in litters, like puppies, because they're born out of giant clouds of hydrogen gas. And among the most beautiful objects to see in the sky this time of the year, the Praesepe, sometimes called the beehive cluster, and the beautiful Pleiades in the winter sky are among the most beautiful objects, not just in binoculars, but in all of astronomy. I hope that you'll check it out. Now, remember, I call this the beehive cluster, but Praesepe actually means any enclosed surface, enclosed like a box or something like that. And so I tend to translate Praesepe as manger. Why do I do that? Because of these two stars on either side of the Praesepe cluster. Right here, Ocellus australis and Ocellus borealis. Any Latin scholars in the crowd? And what do those two terms mean?
Why,
Stand and deliver. That's the kind of teacher I am.
the Ocellus borealis would be the northern,
You can say it.
the northern ass.
Not that kind of ass, the other kind.
And the Ocellus australialis, of course, is the southern ass.
So why don't I translate Praesepe as beehive, which is what's common, because you have two asses, two donkeys eating at the manger. Thank you very much. I've always wanted to say that. Now, of course, the stars rising over here in the east. I'm going to advance the time a little bit so that we get to what amounts to summer skies, just before sky. In the evening, and this is what it would look like in the morning, tomorrow morning, if it's clear, and I'm afraid you'll need to go to those mythical dark rural skies to see this one. And you will see a beautiful stream of silvery light stretching across the sky, as the Aboriginal tribes people of Australia put it, like the backbone of God. And what you're looking at is the Milky Way. And why is it called the Milky Way? Because the ancients thought it was made of milk, which, by the way, is a pretty good story. I see there are some kids in the audience. Ask me later. It's a really good story. But this gives you some sense. I mean, what you're looking at are the unresolved stars of our galaxy, the Milky Way. And when I say our galaxy, I don't say the galaxy, because you are a part of the Milky Way, and the chair you are sitting in is part of the Milky Way, and our planet Earth is part of the Milky Way. Beautiful collection of stars that we have only known is that for about 400 years, for the tiniest fraction of our history on the planet. For all that time before, no one knew. Until this fella came along. Perhaps you've heard of him. His name was Galileo. And he had a toy, recently invented by some glasses spectacle makers in Holland. He made some improvements in the design. And you have to understand that it really was a toy. Used a little bit on the ocean to look in the distance, perhaps. But the way most people use their new toy was like this. Oh, look, there's a tree over there. Oh, look, the tree looks bigger. Galileo had an idea. An idea so ridiculously simple, yet so profound, that it changed the world for all the people who lived after. It changed the world for you, and it will change the world for all people yet to come. And it leads me to believe that every single person sitting here has such an idea. It might take you your whole life of study and contemplation to find it. But Galileo's idea was so simple yet so profound, I am convinced that you have it. Why am I convinced? Because Galileo did this. He pointed it up at the sky, and he discovered the craters on the moon, and the moons of Jupiter, and the phases of Venus. But the thing that he discovered that rocked, that changed your world, was that one fine summer evening, he pointed that telescope at that glorious Milky Way. And he discovered that it was made up of uncountable stars. Now, it took a while to figure things out from there, but in that sweep of his arms, Galileo made the universe bigger. Remember what it was? That place so close to you that if you had a ladder tall enough, you could reach up and touch the edge of everything that is. But now and since, the universe is vast beyond measure and made up of uncountable stars. In other words, Galileo put us in our place, and he did it by doing this. You have such an idea. Search for it. Find it. You too can change the world. Now, big enough for you? Well, it isn't big enough for me. I'm going to turn off some of these stars. Oh, the power. Because it turns out that we and all of the stars that you see in the sky and all of the stars in that silvery band of light make up a place we have come to call, and we have called, our Milky Way galaxy. Oops, that's not what I wanted. That's what I wanted. A spinning whirlpool of 300 billion stars. Skinny when seen from the side, with a beautiful central bulge. And before you think too much of yourself, my friends, realize that we are not here in downtown Columbus. We're out here about 2/3 of the way out one of these spiral arms in Piqua, my friends, which turns out to be, come to think of it, a pretty good place to be. And our galaxy is so big that if you turned on a flashlight at one end, it would take the light 100,000 years to get to the other side. Big enough for you? Well, it still isn't big enough for me. One of the questions we get over and over again here at Perkins Observatory is, I think, I want to buy a telescope. And can you make any recommendation? And I say, well, you should get yourself a telescope with at least a 6 or an 8-inch mirror, and it's going to cost you about $450. And they go, $450? But, my friends, you could take that telescope that costs $450 and just spend an evening, as I spent long ago, just looking at galaxies from a dark, dark rural site. I saw over 150 of them that night. And come to think of it, you could spend a month of clear nights doing that, or a year, or your entire lifetime, and perhaps even with a slightly bigger telescope, your children's lifetime, and their children's lifetime, and still not see all of the galaxies that you can see in that $450 telescope. And that fine night long ago, I looked right now in the early evening, just rising high in the south, at the constellation Virgo and Coma Berenices, at the Virgo cluster of galaxies. And as I looked, and as I observed, they don't look like much in a telescope. Many of them simple oval-shaped so-called elliptical galaxies. That one, M87, has 1 trillion stars in it. And I realized that as I looked at those galaxies, the light that I was seeing took 65 million years to get to my eyes. When that light erupted from those trillion stars, the light that I was seeing at that moment, dinosaurs were disappearing from the earth. Now I've talked too long. I usually allow time for questions. I only have time for one question tonight. And to make sure it's a really good one, I will list it. By the way, just because a scholar always gives his sources, I stole that joke from Kurt Vonnegut. But I do have a question for you. Does all of this make you feel the tiniest bit small? Perhaps a little unimportant? Well, it shouldn't. Because you have something inside of you that makes you more powerful than a hydrogen bomb star. And you have something inside of you that makes you vaster and more wondrous and, dare I say, more beautiful than a galaxy of hundreds of billions of stars. And the reason that you are more powerful than a star is that a star is stupid. That a galaxy as big and as bright and as beautiful as it is will never know its great size. It will never know its great beauty because you have something inside of you that gives you the power to know these things, that gives you the power to look up at the sky and down at the world and around at these miracles we call people and see them with knowledge and with love. No star can do that. No galaxy has that power. We have seen, in brief, a universe of great vastness. And in all of that, some of its tiniest parts, you have developed by design or by accident, take your pick, the power to know these things. You are the part of the universe that has come to understand itself. You are the mind of the cosmos. You know, I've said this a million times. I never quite know how to say it. I'm really out of time, so I'll come right out and say it. I beg you. I beg you. Learn something new. Learn 1,000 new things every day about your universe and your world and the people around you. I beg you. Don't waste that great power. And that's all I have to say about that. Thank you very much. questions about astronomy, I'll give it a try. But we just happen to have some, people from the physics and astronomy department here at the program. Professor Bob Harmon, Professor Barbara Andrek over here, and Ron Stevens, who just recently got his degree in astronomy from Ohio Wesleyan University, which, by the way, is a very fine university. You should consider going there when you graduate from high school. Thank you very much. I got to plug in. We'll take a little break and maybe